So the topics that I'm going to cover, a lot of them are here. So these are always good places to look into. So we covered last week the technical discussions, the project management, cloud onboarding, but let's get into some of this stuff here, which is a pretty fun topic. And then also we'll see if we can get some of the virtualization and containers material today. We'll just kind of see where we're at. So let's first start with this cloud service model and go there. So I'm going to share my screen, and here we go. Okay, so in terms of what we'll cover today, again, is I'm going to, we covered last week, week one, we got into effective async technical discussions. And then this week, we'll get into cloud computing foundations, and then potentially even a little bit of this as well, the virtualization and containers. But first, let's start off with the cloud service model here and talk about that a bit. So this is a really important concept to be aware of, is this cloud service model concept, and why is it so important, and what are the reasons for it being something you should know, is that it really can help you identify how you should solve a problem. And in particular, the software as a service is a good place to start. So software as a service is a hosted software product. Really good examples are Google Docs, maybe Office 365, and you're using the service. In fact, what we were just talking about, Circle CI, that's software as a service. GitHub Actions, that's software as a service. It's something that somebody built, you pay for it, you use it, and it solves a problem. This is really helpful when you're building a company. And my experience in the Bay Area building companies, most companies, they'll decide to use a lot of software as a service products. In fact, one of the hot companies right now in that space is a company called Datadog, which does monitoring around software. So it basically has a bunch of tools where, in fact, let's just look at this real quick. This is one of the hottest, Datadog. This is one of the hottest companies right now in cloud monitoring as a service. Good example, right? And why would somebody do this? Is that you can't solve this problem at the same time as doing the problem that you're doing at your company, like building a content management system, or selling mobile apps, or building whatever it is you're building. You don't want to also spend time here. If let's say it costs you $500 a month to use their software, it's actually a great investment, right? It's really the concept of opportunity cost. You want to spend your time on the things that matter and delegate this stuff to other people and pay them, a few $100s a month. So that's really the core concept of software as a service. With platform as a service, this is a little bit different. Platform as a service is a way of developing code where you focus more on the business logic, and you can actually think about this like the example I give here is a self-service car wash versus a drive-through car wash. In the drive-through car wash, you just drive through, a car gets washed. It's a lot like that. You write some Python functions, Ruby functions, Go functions, and then that automatically gets deployed somewhere. And one of the first big ones was Heroku. And if we take a look at this, you can see Heroku. And these are all the different examples of this. But really, you can just focus on writing code, deploying the code. And in fact, we'll get into this in a bit, of how you can build things that automatically deploy, and it's really an easy way to kind of get started with this stuff. And let's make sure we got everybody here. So next up, let's talk about infrastructure as a service. So infrastructure as a service is much more low level. So this would be like Costco, right? If you go to Costco and you buy a bunch of beans or rice or some kind of bulk item, you're going to save a lot of money because you don't have to pay the retail cost of it. And so you're getting this wholesale price. That's a lot like what infrastructure as a service is. But what are the downsides of infrastructure as a service? Just like, what's the downside of buying a 50-pound bag of flour at Costco? Well, you better know what you're doing, right? You need to know how to make bread. You need to know how to store the flour so it doesn't get insects. The beans, if they're pinto beans, they may need to be processed first soaked in water. There's a lot of technical detail, just like with Amazon, there's a lot of technical detail to use the virtual machines, to use the S3 storage. So this is probably the most common for a sophisticated company is they use a lot of infrastructure as a service because the cost is low. The downside of this, though, is that it's really easy to get burned if you don't know what you're doing, and it's a little bit like a gym membership. And so maybe I can just draw that out real quick, is that I think that most people that have been doing the cloud for a while realize that there's almost like a subsidy happening with the cloud, in that your skill level really dictates how much it costs. So let's just say, for example, maybe I can just draw this out real quick, what this would look like. Okay, go here. All right, let's just hook this up. So the gym membership concept is, think about, let's say, the typical gym. Now, they all may go out of business now, but let's just think about, how does a traditional gym make money? Well, what happens is, if you've seen this, is that on January, at least this is the case in the United States, in January, you get maybe 90%, or let's just call it 80%. 80% of all the customers pay for a year in January. And why would they do this? Is that they have the desire to get in shape, and they want to be fit, and they want to be healthy, and then they start. This is a New Year's resolution, right? But unfortunately, what happens is that as they go through and they sign up for the gym membership, February, the majority of those people aren't there anymore. So that 80% that came into the gym and paid for it, they pretty much have paid for the gym. So that's why you can go to the gym and get all this really fancy equipment. And then February, let's say that of that 80%, let's say that was 80 people, maybe 10 of them are left, right? And then maybe in March, maybe another 5 are left, right? And then by the time you get down to December, maybe there's like 2. It's a little bit like that same model with cloud computing, where with cloud computing, your skill level in using the services really dictates whether you're successful. So, the cost could be, let's say, here, and then maybe your skill is here. And so the people that are really skilled, their cost is here. Or I'm sorry, the people really skilled, their cost is low. And then it basically goes down, right? The less skill you have, the higher your cost, right? So basically there's a there's a power law where you can get very low cost. Like you could, I don't know, let's say that's $100 a month that you could spend. But then at this angle, these are people that are very low skilled, and maybe they're paying $10,000 per month. It may be the case you do need to do this, but in general, that's what my observation has been with infrastructure as a service, is that it's a lot like the gym, where you have to be very careful, or you're the person that's going to be paying for everybody's gym membership because you didn't go to the gym. And that's why the skill level is very important in terms of cloud computing. The other models to be aware of is metal as a service. This used to be more important than it is now. But in the old days of creating cloud computing infrastructure, it was often, the performance was very bad because the virtualization technology wasn't that good. And so there was this kind of back and forth. Should I use physical servers? Should I not? And one of the things that's happened is that they have really made the virtualization very good. And so it's not that common to need physical hardware, but there are ways that you can control it like the cloud. In fact, Amazon has that. You can control a physical machine like a virtual machine. Serverless is another one. So for example, with serverless, you can go through and build your technology by using, let's say, an AWS Lambda function. And you can really focus on writing a function versus managing a server. And what's nice about this is that a lot of the irritating stuff in the skill level that you have to have starts to go away because you can build things that take advantage of these cloud native environments. So a few things that we'll discuss here would be to go through and think about this concept in three different kinds of websites. So I don't know if we have time to get into all of this today, but these are things that you could go through on your own. Is that this is a demo of how to build three different websites, right? And in particular, what's neat about this is that with Amazon, you can build a website with just an S3 bucket. And the way you do that is you set up static hosting. And again, it's actually shown in this screencast. You can take a look at it. Another way that you can build a website is you can literally just put a function together inside of Lambda and then serve that out. Now, we'll actually run that in a second because it's pretty easy. Or the other one would be that you could actually deploy a physical virtual machine as well. So I think this would be worthwhile going through and just playing around with it when you have some time on your own. But let's actually just run one of these. Let's just see like what a Lambda based website would look like. So if I go to console here and I get into the AWS environments, one of the things I can do is go to Lambda. And Lambda is one of my favorite development environments. And the reason why is it's really simple to build stuff. And so if I go here and I say create function, I can pick author from scratch and we'll just say hello web demo. And I will put the Python 3.8 environment and then just say create function. And this is essentially doing the same thing that a virtual machine would do, except for it's much more lightweight. And once this is set up, I'm ready to go here and I can start writing code. And what I would typically do is build something really simple to start with to just show you, how trivial it is to write code with Lambdas. And what I like to do is build a Marco Polo function. So the thing to point out here is that the event is what gets passed in. It doesn't have to accept an event, but if you do want to do something with it, you would process event. And I could say if event name is equal to Marco, do this, return back Polo, right? So you can see it's a really simple function. But I also could say return back not Marco, right? And I could even put in the string that was passed in. I could say not Marco and then put in, let's say, event name. Like if somebody passed in, somebody passed in something that wasn't the word Marco. So if I save that, if I want to test it, what I need to do is create a test event, and I can just say here Marco, put in the word name, and then go Marco. There we go. All right, format it, create it. And then if I test this, you can see that it returned back Polo because it matched that name. That was the JSON payload. And if I want to even print out what the event is, I could even go here and just say, this is my event. And then you can see that as well, just to make it a little bit more clear. But the core idea here is that it's really simple to build out. There we go. Here's my event, to build out these Lambda functions that are essentially like a lighter weight virtual machine. And if I go and I make one that doesn't match it, let's just create a new one and we'll use that as a template and we'll say Bob. This one will do the other line of the code, the other if statement. Go ahead and save this, create it, test it, and it should say not Marco Bob, right? And it says this is my event. So these are really fun to build because of how trivial they are. Now, if I want to kind of swap this out now and do something like I have in this example, I could take this and just throw this in there. And what this will do is this is basically like a website, right? And what I do is I don't even need to do anything to the event because it doesn't need anything to be passed in. It doesn't hurt to have something passed in, but it doesn't really solve any problems. And then I can put a string here that just has some HTML. And that's what it returns. And then I put a response code here like this. And this will actually figure out the content type and give me back an HTML web page. So if I save this and I go here, what I can do is look that that's actually the website that's running. So how would I deploy this? Well, I could actually just add a trigger, and this is where it turns into a website. I just go API gateway, just like that. And I just say, what do I want to do? Let's just create an API, and I just want to do a regular basic, HTTP API, and I just say anybody can talk to it. I add it, and that's really all I need to do. And from here, I can just find it. I can just click on it, I think. There we go. And if I go to details, I think it'll give me the URL. I just run this. There we go. That's it. So this is a publicly addressable website that's just sitting somewhere in the cloud, and I can build it out. And you can see I just click some buttons, put some code in there. If I want to change it, pretty easy to change, right? I can go in here and I can go back to my website and write new source code, say hello website Lambda. This was trivial. Like that. Save that. There we go. It immediately should pick up the change here. And if I go back here, I think that there we go. Right, it's instantly there. So this is really can make you spoiled because of how easy it is to build web applications and hook up events. And later we'll get into how you can actually hook these into other events. But that's the gist of it, is that it's trivial to build these web applications. You can see like it's just a little bit of code. So what I would recommend is that I showed you the easy one, is go through here and go through these exercises, try to build a virtual machine one, build an S3 static website one, and then also do one with an actual virtual machine where you can follow the example, and I walk you through all of those in here as well. And this will give you a good feel for those infrastructure as a service, platform as a service, serverless, and kind of decide, what are the places that you should be an expert in, where should you not be an expert. I personally like this. This is where I spend a lot of my time now because I already did that in another phase of my life, and I don't really want to be an expert in some of that anymore. Okay, so that's really the service model. Let's talk about infrastructure as code a little bit here. So infrastructure as code is a pretty interesting topic, and in particular, let's just whiteboard what it is. and why would you care about it? So infrastructure as code is a big topic because of the fact that something somewhere has to wire everything together. In the old days, let's just call this pre-cloud, it was really a nightmare. And when I started in IT, I was working at Caltech in 2000. And when we had to provision a machine, it was literally you take a server, you put it in some data center somewhere, and then you rack it, and then you have a mouse and a keyboard, and you click some buttons, and there were some tools that we would use. Like I used some software called Radmind that people were using that would automatically monitor some software and kind of figure it. There was Solaris, which had Kickstart, which you could kind of boot off of a machine. But in general, it was pretty crude. It was pretty crude, and it was like a lot of humans, right? Where the humans were doing a lot of the work, and that's how you know that there's problems when there's tons of humans, lots of IT bureaucracy at universities, at IT. A lot of these jobs are just gone now because this was just clicking buttons and configuring things. In the cloud era, it's totally different now because of these concepts of DevOps and also GitOps and also infrastructure as code. And really, you don't need any of these specialized people anymore. If you're a developer, you can just build this yourself. And so in general, GitOps is a fancy way of saying that inside of a Git repo, what you would do is you would hook into that repo your actual deployment code as well. So you would have your deploy code, and you would have your source code, and then you would have your test code. And so what happens is the deploy code is literally the infrastructure, right? And in the old days, again, this was like humans, and then you're pulling machines out and you're pushing buttons and everything. Now you can actually deploy your entire infrastructure as lines of code. And in fact, let me give you an example of this. I have one really recently that I did. And so if we look at the Azure one, that's a pretty good example. Here we go. Flask, machine learning, Azure. Where's my infrastructure as code in here? Well, it turns out all I needed to do was this config file here is infrastructure as code. And what happens is that I define what my web app is in YAML. And most infrastructure as code is kind of this lightweight format, either YAML or Python or some kind of, I know Terraform has their own kind of lightweight text format. I have a virtual machine, I have an environment name, I have a version of Python, and then I have the different setups here. I have the build stage, I have the commands here, and as I scroll down here, here's the deploy. This is the infrastructure that gets deployed. Is it takes that information, is it tells it to run, and that's it. So it's just some configuration data, and I check that in. The Azure pipelines is one example of that. There's Google Code Build is another example. There's CloudFormation from Amazon. This example. There's Pulumi. That's another example. There's Terraform. Let me show you some of these. So we have Terraform. This is a pretty hot company right now. And this says use infrastructure as code to provision and manage any cloud infrastructure or service. And really, this is a good example. Is you write this declaration that says, okay, here's my network, here is my virtual machine, here's how they wire together, and it's checked into the project so your build server can verify it, and you know exactly what's happening. So that's really the advantage of infrastructure as code, is that everything you need is in this particular project. So if I go back again to this Azure project, I could give this to somebody, this exact project, and say, look, I've got the build system hooked up, I have the application file, I have the deployment file, I have the machine learning model, I have the way to predict it, and I have the packages that you need. All of these are inside of this project. So 100% of everything I need. And that's the core concept with infrastructure as code, is that you've got everything you need in one package. And again, let's just maybe draw this out and see what are some of the players in infrastructures as code. So the core players here in infrastructure as code is that you've got the specialized companies that are doing it. And so who are these companies? So we'll call this non-cloud companies, and we'll call this third party. And who are these players? The main players in this space are Terraform and then Pulumi. Terraform. And so I showed you Terraform, and then here's the other one is Pulumi. I'm probably going to completely butcher their name here, but let's see if I can find it. Pulumi. Yeah, Pulumi here. So these are the main players. And Pulumi, was it spelled? Yeah, okay, good. I spelled it right. And so why would you use this, right? Like what's the problem they solve is, in theory, you could write multi-cloud code. So that's one of the things that you could do with these providers, is that you could write something that's abstracted enough that you could deploy, for example, to GCP, to AWS, and then maybe to Azure, right? That could be like the environment that you're working in, and then you've got the cloud specific infrastructure as code, cloud vendor, and so these are a little bit different. And let's just compare. You've got on AWS, you could use CloudFormation, and so CloudFormation is their native language. It's a little bit verbose. I think it's like a little bit much for me, but let's just show you this real quick. Let's go here and we'll say CloudFormation, AWS CloudFormation. And basically the way this thing looks is that you can check the infrastructure in, put it into S3, whatever. And I think they have some examples of it here. Let's see. Here we go. Get ready. And maybe we can see like a little sample of this. Like here's one that we could look at. Stack ID, events, resources. Where's the? You can see how much I use it. I don't even. Here we go. View in Designer. So if I look at View in Designer, it shows you like basically this way of building out the infrastructure. So it looks kind of like a lot of the other ones, except for this is like a nested JSON structure. JSON and YAML are very similar, by the way. But you can see that you could start to write out your code as YAML. So I mean, there's some interesting things about this for sure, and that would be one example. But again, this is their own proprietary way of doing it. And then let's say if we took an alternate road is you could also say that their build server, which is AWS code build, is also a way of doing infrastructure as code. And in fact, I could give you an example of that, which is if I go to my personal website or something like that. I think I have it. I have some infrastructure as code in there. Let's see here. Let's just go to this. There we go. There it is. So this website, I have some buildspec.yaml, and this is similar, right? Like I go inside of here and I put some examples. I grab some Hugo, which is a website technology, and I put this in there, and it does stuff. So you can also use the cloud vendors build system as well. So that's another thing that you'll see. And so really the what you'll see with these cloud vendors, if they're Azure, if they're GCP, is that often you have their like native way of deploying, plus they have the build server, which I would still call infrastructure as code. And Google, you could call Kubernetes, which they have their own language for doing infrastructure as code, or they also have their own code deploy system as well. So it's like, I think it's called Cloud Build, or I forget. It's a build server that deploys Google App Engine. So that's just really the lay of the land. Is you've got the third party people who, there are some interesting things going on there, in that these are potentially like $1 billion companies, but also you have the cloud vendors themselves, and these cloud vendors are also have their own versions of this. So it's just something to be aware of. This is the lay of the land in infrastructure. There's no particularly right answer, and there's pros and cons to both. Now, if we go into some of the older versions of infrastructure as code, and these are all things that I've had some experience with. There's Chef, there's Puppet, there's Ansible, and these are really, I would call it like the first generation. And what those did was they would kind of convert this syntax into like recipes where you would deploy the software. But it feels like these technologies are starting to really take off: Terraform, Polemy, and then also the cloud native systems. And then, as I mentioned, Helm, that's part of Kubernetes. They have their own Kubernetes example. So that's infrastructure as code. Now, another thing to be aware of is this concept of continuous delivery. And this one is, I think, worth getting into today, which is building on the continuous integration stuff that we did before. So what is it? Why do I care about it? Well, the core concept here is that you can build software in real time, so that every time you make a change to source control, you're able to go through and build a new, deploy the changes. And a really good example of this would be Hugo. Hugo is a static website generator. It's pretty popular. And one of the things that you can do with this is you could actually have Hugo be deployed by building the software first in Cloud9, and then developing it by checking it into GitHub, and then creating an AWS code pipeline to actually deploy it. And there's a whole video that you can watch where I do this. And these are the steps: is, step 1, launch a Cloud9 environment. Step 2, download the Hugo binary, build this out, and make a new website, deploy it. So I think this is probably a worthwhile demo to do. So I'm going to just open this up in another window so that I can actually kind of walk through it and just take notes while I do it. So I'm gonna just walk you through this concept and show you how important it really is to think about continuous delivery. So first up, let's go to Cloud9, and I'll spin up another environment again. So we'll go here and go to Cloud9. And the first thing that I would do, I think I already have an environment that I can probably use. I'd probably use one that was an older one. I think, I don't even know anymore which environment is which. Sure, let's just do it from scratch again. So I'll create this. We'll call this Hugo demo or something. There we go. And say this is an environment for building Hugo websites. There we go. Next step here, I can choose what kind of environment. I'm going to leave everything default. I don't need anything tricky. I'm going to say next and create the environment. Now, the reason why I think Hugo is great for this is that it's trivial to build stuff in Cloud9 because it's a Linux environment. It's got everything set up, where if this was my laptop, it could be a little bit painful because a laptop doesn't, you don't know what's on your laptop. It could be Windows, it could be OS 10, it could have weird stuff in there. But when I use this cloud environment, it's kind of like a fresh start for me to build stuff. So that's what I'm going to do. I'm going to set up this Hugo continuous deploy, and while that's spinning up, or continuous delivery, I'm going to put this in another tab here, so I can refer to it. And actually, just while that's almost finishing here, let me just really briefly just say what continuous deploy is, or delivery, and just differentiate between the two things, because it's very confusing to most people. They're like, wait, what is CI/CD? So you'll hear this a lot. You'll hear CI/CD, and you're like, what does that even mean? So continuous integration, or CI, what this is just testing your code. So I have Git or GitHub here, and every time I make a change, I have some robot that, in this case would be GitHub Actions. We'll call this GA, GitHub Actions, goes through and it tests my code. That's it. That's really that's the feedback loop. That's all continuous integration is. Build my software, test it, lint it, do whatever. CD is a little bit different in that what it stands for is delivery. And what it means is that your code is always in a deliverable state. And this is really subtle, but how could that be? Well, one, we just talked about it, is infrastructure as code is a big deal. If you don't have a templated out infrastructure, right, where you can easily create a dev environment, a staging environment, a production environment, a whatever environment, then you can't do this. But if it's fully automatic, so that, let's say you have a branch-based delivery system where you have maybe the master branch, you have a staging branch, and then you have a production branch. The way I've set this up typically is that I trigger on each branch has a different environment that it is responsible for. So the master branch would provision this stack like this, and then the staging branch would configure this stack, right? Here we go. And then production would configure another. So all of this is done via the different branches in the infrastructure as code. So each one is slightly different. And then my code, let's say in this case, the website is, as soon as a change is made to GitHub, it's now deployed to production, .com or whatever. And that's really the main difference, is that the testing still happens, but there's one final step, which is it also automatically gets deployed, and you can make a change. So this is really powerful, and it changes where I've even in 2010, I was working at companies that were huge companies, and it would take 1 week to deploy software, and people had all kinds of excuses why it was okay that it took a week to deploy software. It was a bad excuse. But with continuous delivery, you can make 20 changes a day, right? You can do a lot of changes because it's all completely turnkey automated, right? So that's the core concept, and that's what we're going to set up with Hugo. So let's go to this environment here, and the first thing that I'll do is Git, let's see here. I'm going to grab Hugo. So I'm going to go to the Hugo release here. So we'll go here and we'll just throw this. Actually, that's not what I want. I wanted this one. I want to grab here. So here's Hugo. Here's the latest releases. You can see one was made just 23 days ago. And so I know that that's the version is 0.74.3. So I can just kind of put this as a variable inside of here, just say this. And then I'm going to use this command wget. Whoops, I didn't mean to run that. I want to change this to point what I had up here earlier, which was, I think it was 0.7. That screwed up my, 0.74.3. 0.74.3. 0.74.3. Let's grab the latest one. Hugo point 2.74.3. There we go. Okay, so let's go ahead and download this. Does this work? It looks like it does. So I've got two files. I'm going to remove that other one, this older one, 6.3. Okay, so next what I'll do is I'll just unzip this. I can just tar this or untar it. So this is the way I do it typically. And just go like that, untar this thing. And then I can say make dir -p tilde bin. And this will make it so I can put this in my path. And then I will move this Hugo file into the bin like that. And now if I type in which Hugo, if I just go to CD or something, I say which Hugo, there you go. We can see Hugo's there. So now I can test it out, and you can see that's ready to go. So Hugo, I can even say Hugo help new, and it'll tell me information about how it works. So Hugo is pretty cool because you can build a template really easily here. And so that's what I'm going to follow next year. Is I'm going to make a new Hugo website. So the way I will do that is I will type in Hugo new site quick start. So let's go ahead and first get into the environment here, and I will just kind of remove the rest of the stuff because there's a bunch of noise. So remove all this -rf. You kind of want to be careful with rm-rf, but Hugo new site, there we go. And you can see it puts this directory here. It's a bunch of files. So what I will do is cd into this, and I will also actually, you know what I'm going to do before I do this is to make it a little bit easier, I'm going to remove this quick start, and I'm going to first get GitHub set up, because that GitHub is going to be the thing that does the auto deploy. So I'm going to go to my GitHub, and I'm going to create a new repo. Let's go through here, and we'll just say cd Hugo, continuous delivery Hugo, right? And I'll say initialize README. Maybe I'll say Go. I want to ignore any Go files, and I'll say create license. Perfect. If you remember, it's going to ask me to create SSH keys because I didn't do that yet. So I'll just go ahead and bite the bullet and solve that real quick. So I'll type in SSH keygen -t RSA, make these great, and then I will cat this file. There we go. Let's cat it like that. Next step, I will take this and go to this directory and find SSH and GPG keys and make a new one. There we go. And we'll call this one Hugo deploy. And that should give me the ability to kind of check this code in. So I think this makes it a little bit easier, because now I can say Git Clone, and whoops, I don't want to do that. Let me just wipe that out. I can say Git Clone and go to that repo that I just set up. Here we go, code, copy this, and I can put that into this repo, which makes it a little bit cleaner. So I'm going to go here. There we go. And I will cd into that, the Hugo. And then from here is where I'll do the quick start. So in fact, actually, before I do that, let me do one more thing. I'm going to do it at the top level and then copy the quick start stuff inside of there. So let's do a Hugo new site quick start. Right. So this is above the Git repo. There we go. And then I will cd into the quick start directory, and I'll just say cp-r everything, and then I will put it into Hugo repo that I just set up. Right. So the reason I'm doing all these tricks is that I want to make it easy to just check this code into GitHub. So there we go. That looks good. And now I can get rid of this directory, quick start, rm-dir quick start. There should be nothing in there. Oh, well, I guess there is because I didn't delete it. Let's delete that. Okay. And then from here, I just have this one repo. And in fact, if I want, I can just check this code in and get it cooking right now, just kind of get the ball rolling. So let's go ahead and do that. I'll just say git add star, git commit, and say adding template for Hugo. Okay, there we go. And then the first time I do a commit, again, I have to do that irritating hoop jumping here. And this hoop jumping will be that, put in my name, and then I will fix the email here. And then I will reset the author, and then I will be ready to go. There we go. Okay, let's write this out. Exit, git push. Okay, great. Now if I go back to this repo here, this should have the template of Hugo ready to go. Okay, so good. Things are looking pretty good. And so then the next thing that I'll do is I'll add a submodule for a sample project. And the reason, this is how Hugo, you can deploy like themes to it. And so in this case, I can say git submodule add, and it just grabs some theme and just puts it inside of here. So great, I've got that working. And then from here, I can actually echo out what the theme is inside of my config file. And this is where everything is controlled in Hugo. So I can even look at that real quick. If I go to config, you can see it's just a simple type of config file here. So I go through here and I say echo, and now I put the new theme, which is this theme, which is the one I downloaded. So pretty close. We're pretty close to go, ready to go. To create a new blog post, it's just Markdown. I can just do this. I can just say Markdown, Hugo, make new post. And then I could even put some stuff inside of there. If I go to the content, I can edit this out, my first post, and I can just say draft false, and I can just say my posting from Cloud9, just like that, and just say this is some text I wrote in Cloud9, big tags. There we go. Now that I've got that running, I can just run it locally. And the way that you can just actually write this out is if you type in the word Hugo, it'll actually build out. You can see in 84 milliseconds, it built out an entire website, which is pretty incredible. So if I want to run it locally, though, and test it out, what I'll need to do is open up some security holes inside of, or some security rules inside of the Cloud9 environment. So to do that, I'm going to open up the AWS console here again. and from here, I will go to running instances, and you should see that this thing is now available, which is this. It's going to be there we go. I just have this guy available. So I'm just going to click on this and look at the security groups. So this is a virtual machine that's running. That's how they do their cloud-based development environment. And if I scroll down, you can see here's the security group, and I could look at the inbound rules. And so if I want to change those inbound rules, I just click on this. And if I want to connect to this physically and run a server, what I would do is I would go to inbound rules, and I would add a port 8080 and let anybody in the world access it. So let's go ahead and do that. Let's add a new rule, and we can just say everybody in the world can access this. And the port will be, actually, let's not mess with this. Actually, let's not save this. I don't want to mess that up. Let's do it again. Let's go edit inbound rules, and let's add a new rule. And I want to do custom port, and we want to say 8080, and then I want to say anybody in the world can talk to it, and just say this is Hugo development. There we go. And once you do that, then I can say save rules. There we go. And if I go back here, I can type in, I think I would just need to go to curl IP info. This shows me what my host is, and I could now go to Hugo and tell it to bind to that port. So I would say Hugo serve, and then put in this IP address, just like that. And so basically bind to this IP address and then serve it out to me in my house, right? So I can connect to it. So let's do this. That looks good. Looks pretty good here. Let's just double check that that is the right. Yeah, that looks pretty good. Oh, I have one extra slash. I'm glad I checked. There we go. Extra slash. Okay. And now that I've got that, I should be able to run this. Let's go a little bit more right there. Let's go to here, run it. There we go. So it's waiting for me to make changes. And then if I want to connect to it, I can just click this button and just say, actually, I don't need to even do the browser view. I believe I can just go here, and I can just throw this into a new tab and just connect to it. There we go. There we go. Here's my website, and look, it says this is some text I wrote in Cloud9, big tags, right? And I can even change it in real time, and it'll change it. So if I go back here, I can say big tags, the best people, you know, it is what it is. All kinds of really knowledgeable quotes. Here we go, right? And it instantly is making these changes, right? So what's great about this is that I have now a full setup, and I would love, though, for this to be 100% automatic so that I can make these changes without doing anything. So how would I do this? Where basically the code will be auto-deployed for me. So what I'm going to do next here is I'm going to create a static website bucket, and then I'm going to tell my code to deploy out of that. So this is really pretty awesome, is that if I go back to AWS, you can create buckets that deploy code. So I'm going to go here and go to S3 and go like this. And what I will say is I'll just delete some bucket that I've got. I've got tons of extra buckets here that I don't need. I don't know. First one, here we go. Web scraping, or Athena. There we go. That looks like a good one to delete. I'm just going to click on it and say delete. Let's see. Athena query results. I don't need that anymore. Hopefully there's nothing in there. Okay, good. So now I can create a new bucket, and we'll just call this Hugo CD demo. Hugo CD demo. That looks pretty good. And I will just gain next, and I want to turn this off. I want everybody to access it because I'm building a website, and I will say, I acknowledge this, great, create the bucket. Next up, I'm going to create a bucket policy. So I'm going to go to this Hugo bucket, and I'm going to tell it, hey, I want you to let me do demos and serve out websites. So I'm going to go to, I think it's under, it is under properties maybe. Yeah, I can go to static website hosting and say, use this, and I'll say index.html and save that. And I believe the only other thing I need to do is go to management. No, I need to go to, where is this? Access points, permissions. Here we go. Yeah, permissions. And I say bucket policy. And then I also want to throw in a bucket policy that lets people access my bucket. Now this bucket is named Hugo CD demo. So I'm going to just tweak this. It's going to be Hugo CD demo. Hugo CD demo, right? And so what all this means is that people can read stuff out of my bucket, which is what a website does. And this S3 system is got 11 nines reliability that I'm storing this in. So it essentially almost never, like a millisecond a year, goes down. So this is probably the most reliable possible way to serve out a website. Say this bucket has public access. Great. That's exactly what I want to do. So I think we're ready to go now. And when it's done, I can now manually deploy this software. So how could I do this? Well, there's a couple different ways that we could do this. One way to do it would be to tweak the config file here and add like a deploy step. And so if I go, I could either copy that or I could look at my own config file. I think I'm going to make it simple here, and I'm going to look at the way I do this. When I do a deploy, I do this. I do like a AWS sync like this. So I'm gonna do a similar command here. Is I'm going to stop this. I'm going to paste this code inside of here, and I'm going to say to the AWS command here, sync my bucket and sync the public directory. And by the way, before I run this command, let me actually just show you that when you type in Hugo, that's what builds it. So when I was serving it, it didn't build the files yet. So those changes that I made, like the best people, it is what it is, all those that nonsense, I just printed that out first by creating HTML pages by typing the word Hugo. So next I'm going to sync this, and I'm going to go here, and I'm going to go to AWS S3 Sync, copy the public folder that's got all my HTML files, and put it into the bucket I created earlier, which will be this bucket, like this, Hugo CD demo, and we'll put the slash on there like this. Perfect. And that looks good. And the delete just says like overwrite anything that's in there. Does this work? Pretty easy to do. In theory, we're good. Now I have a website. It's running in production. And if I go to this and I go to properties, I should be able to find the URL. There we go. Here's my static website. If I click on it, there we go. Right here we go. I've got a website working. I don't know why that part doesn't work, but who cares? This part works, which is important. I think it's because I need to put this URL into the Hugo config because it needs to know what its root domain is. And so you just say this, you just say base URL like that, and this will this will put it in there, right? So this just says, hey, this is where my website lives. If I rerun it, I think that will fix that. Oh, I have to type Hugo again, generate the files, and then sync it up. Let's see if that works. And if I go back here, and again, we still got the stuff here. There we go. So now it works, right? Because I put the base URL. So this is by itself pretty awesome, because I could just build websites that are globally scalable. I could build the equivalent of like Wall Street Journal right inside of Cloud9, but it's not as useful as it could be, because I want to do continuous delivery, which is I want to be really lazy and not touch anything. I don't want to be in a shell or doing all that stuff. If you're working with news teams or something like that, they're not going to get into the shell. I want to just have some files that get changed and auto deploy. So how do I do that? Well, what I'm going to do is I'm going to now set up the cloud native build server. So next up, let me just check this code in so that I've got all the good stuff working. So this looks like it's pretty good to go. Now, one thing to be aware of is that I need to actually remove these files, public files, because I don't want to check this code into GitHub. I want to delete it here because I want Hugo to generate this in the build server. So I'm even going to go to I'm going to add a Git Ignore file here. I'm going to say touch, I think I have a Git Ignore. I'm going to say Git Ignore, and I'm going to tell it to not check in the public directory. So say don't check in Hugo static files, because we want to generate these dynamically. So I'll just type in here, public. Don't check this directory in. And then if I say git status, you should see there's very few changes, right? There's only the content, which are these config files, the git ignore, and the config file. So let's go ahead and do that. I'm going to say git add dot git ignore, git add the rest, and say git status. There we go. These look good. Commit this, adding step before continuous delivery. So we're ready to go. This is going to be pretty exciting. Is now let's do kind of the same things that we've done before with GitHub Actions, but we're going to add the step of also deploying the software automatically. So in order to do that, I'm going to need to go in and hook up a continuous delivery with code build. So to do that, I'm going to leave all these open. I've got this open, leave that open. Let's just open up one more website. Let's open up this one right here. Let's keep it right there. That's a good spot. I'm going to go to code build. There we go. And code build is a cloud native build system, just like GitHub Actions, but inside of AWS. I'm going to create a build project, and we'll call this auto deploy Hugo. Auto deploy Hugo. I could put a build badge if I wanted to. For the source code, I'm going to say GitHub. So this is where it's going to listen to these events and automatically deploy based on these events. Next up here, I'm going to use my repository, my GitHub repository, and I'm going to go through and I think we called this thing Noah Gift CD Hugo, right? That looks right. Let's double check. Yeah, CD Hugo. And then in addition, because we remember we're pulling the submodules that have the actual theme, I'm gonna say, yeah, go ahead and pull that as well. And then as well, you can say rebuild every time a change is made, which is great. If I'm a news team, for example, at Wall Street Journal, New York Times, Washington Post, I would want that. I would want to say, okay, every time my news team makes a change, let's go ahead and do that. And we'll go ahead and do this. And the event type, add one or more web hooks, we would want to say a push. Anytime a push happens to GitHub, let's build it. Okay, now how do we build this? Next, we're going to, I believe, let's go down here. I think I need to do managed image, and I'll say Amazon Linux 2, which is what AWS Cloud9 is. That's the beautiful thing, is that we're basically taking the same environment and keeping it inside of here. For runtime, we'll just say standard. For the image, we will do Amazon Linux 2, x86 version 2. We'll just keep it simple. Environment Linux. We don't need any privileges. We can say code build. That works. Now, auto deploy Hugo service build. Now, this is something to be aware of, is that this role is an IAM role. It needs to make sure that it has the ability to talk to S3. And so that's just something to be aware of. And then from here, we can say, do we want to have infrastructure as code, right? This is the infrastructure as code. We'll go ahead and say, yes, we do. We want to do infrastructure as code here. And also, yeah, we just want to make sure we have infrastructure as code. So what I will do is say use buildspec.yaml file, and what I can actually do is, before I finish this, I'm going to go back to Hugo and just make that file so that it's ready to go immediately. So I'll go ahead and I'll just say touch buildspec.yaml. So create this infrastructure as code, and then I can double click on it, and I can basically mimic something that I've got in here, which is, it should look close to this. We'll tweak it a little bit. So we want to change it to the version of Hugo that we're using. If I type in Hugo -- version, I think it'll tell me. Like if I go here, I can say Hugo version. We're running this one, so we want to tweak it to that. So we'll put that in there like this. And then I believe we only need to change a few other things. So it's going to grab the right version of Hugo, right? It's going to create the Hugo inside of our project, just like we did locally. We're going to remove the public files. We don't, in case they're there. There probably won't be. We'll also put the new S3 bucket. So we know that the S3 bucket is called Hugo CD demo. So let's put that in there. Let's just go here, and we'll just say that's the bucket, just like that. Looks good. And the region is US East, which is a little bit weird, because I think I did before. The command I put here was, if I just type in history, I think I told it to copy in West, which I don't think it matters, but let's just keep things simple and let's keep it the same. So I'll just say, version US, US West 2. Let's just copy, do everything the same way I did it before. And also, let's just double check here that this is Northern Virginia. So will it let me copy to the West version or not? That's a good question, actually. I guess we'll find out. But I think we want to, let's just keep it simple and use the same region, so that I don't screw myself up. So I'm going to just recreate this part. So we'll say Hugo continuous delivery. We'll say GitHub, just kind of recreate this stuff. GitHub account. Failed to log in. Please reconnect your account. Well, that's irritating. Repo. Disconnects. Well, I'm gonna go back then to this other one and just cross my fingers here that that it will work with Virginia. And actually, you know what I can do is why don't I do this? Why don't I just test that I can deploy the code via to the other region here, and just say that I want to deploy the east and just see if that works. Here we go. And let's just do this. So this can be a little bit irritating sometimes, is to make sure that you've got the exact region deploy commands. Let's see. Oh, I have to type in Hugo again to deploy to create the files. There we go. And then let's see if this deploy works. Sync to US East, does it work? Well, looks like it works still. And if I go back here and refresh it, okay, so it doesn't look like there's a problem doing this. So I can keep it with Northern Virginia just to keep it really simple. So again, I can just go through here and say, Hugo auto deploy. You can see how careful I'm being when I do this, because this is something that's going to be running over and over and over again, and it's easy to make mistakes. There we go. It'll be a repository in my GitHub. We'll say no gift, Hugo CD, or Hugo, what is this thing called? CD Hugo, CD Hugo. CD Hugo, there we go, perfect. And if anything, this just gives us some additional practice. There we go, Git submodules, rebuild it every time. We want to select that. We want to do push, and we want to use a managed image, Amazon Linux. We want to do regular runtime. We want this to be Amazon Linux x86-64. We want to say leave that service role, use a build spec.yaml. So yeah, the place that I was stopping before was I just want to make sure that this file looks good. So we got this. We're gonna keep it at US East here. This looks good, so I'll just swap this out. And then I think we're good to go. I think that this should be good. So I've got this. So I can remove the public file, although it won't be checked in. And I'll say get status. This looks good. I'll add this build spec file, commit this, and then it should be ready to deploy, adding a build spec. Okay. And from here, if we go back again to our code build system, I can just say ready to go, no artifacts, and I think we should be able to go. Oh, Hugo auto deploy. We'll just call it Hugo auto deploy. There we go, and keep everything the same. And then this wants something. Hugo code. Type your role name. So this might be a problem. Here we go, code build Hugo service role, is that always make sure that you're using a service role that has the right privileges. And I do document that in the information provided, but I won't go into it just for time's sake. So let's go through here and we create the build project, and fingers crossed. Okay, in theory, this should be ready to go. And if I just click start build, it should be able to start this build. And let's just double check that it actually is able to make a change. Okay, this thing looks like it's running. And I can just close this to give it a little bit more room. And I can look at the logs as well, which is pretty neat. So if I was working at, again, we're talking Wall Street Journal or something, and I set this up for them, we can say, wow, look at this. Look how quick I built it. I deployed it. It looks pretty good, actually. Looks like it's ready to go. Looks like it's a very quick process that we're doing. Awesome. So now, though, let's really test. Well, first, I guess, let's just make sure it looks good. Yeah, it looks like everything copied. Everything looks like it's going pretty well. No problems. And if I go back to the website, it's still running, right? So we know something's happening. To really test this out, let's refresh this. Let's go to content posts, and then we can just say, remove this and just say, data science is better than the highest paid person's opinion. There we go. That's called a hippo, by the way. One of my favorite terms. The highest paid person's opinion. Data science is better than a hippo. There we go. If I change that, we go back here. They should auto trigger this. And now I can just watch it run, and there we go. Boom. Automatically it's running. It's auto deploying. This, in my opinion, is one of the coolest things you could possibly do, in that it just eliminates a whole vector of errors to build software. Is like, I can now deploy website changes automatically. Every single time I make a change here in GitHub, this will auto deploy. So if we go back here again to the website, actually first let's just look at it. Let's just like tail the log files. It's going to be very quick too, like super quick deploy. It looks like it's done. If I go back here, we can remove that nonsense. There we go. Data science is better than hippo science. So I have a full end-to-end continuous delivery setup here. So that's really the change that we made. So let's document this up. Go here and put this into play. So what did we build? We build this. Is that we have a GitHub repository that is the source of truth. So GitHub here is the SOT, source of truth. And we also had Cloud9, and Cloud9 goes through and we can, kind of test out our website, test out the website. We used Hugo because Hugo is just super fast. It's written in Go. And then in AWS, we had two things that we interacted with. First one was S3, and S3 is this object storage system that has 11 nines reliability. So basically, it never goes down. Like, this thing can run forever and ever and ever and ever and ever. And what's awesome about this is that this S3 site can also serve out websites, right? And so this would be a web property here. And we also set up the code build right here. And so what code build does is it can be very nifty and kind of listen to GitHub and kind of spy on it and say, hey, I want to listen to push events. Every time you push a change, I want to do what you were doing in Cloud9. And I'm going to basically, one, build the website inside of my container, and then two, just do a sync, right? So basically just sync the HTML files to the bucket. And so what's awesome about this is like 2 seconds, right? So I can literally deploy something to a system that has 11 nines reliability, which is 1 millisecond of downside time per year, automatically. So this is continuous delivery. So this is why you want to set up continuous delivery, and it solves a real problem, right? This is a non-trivial problem that it solves, and we're taking the best of everything, right? We have a cloud-based development environment, we have a cloud-based source control, we have the cloud itself, we have this super reliable S3 system. We automatically make the changes. All right, so that's that topic. I can kind of put a fork in it and go on to the next topic. So the next topic that I will talk about is virtual machines. And in particular, what I wanted to cover is it somewhat relates to what we are covering, but let me just briefly kind of go into it a little bit, is that the Cloud9 environment is a virtual machine. So, this is maybe the trade-off here is like, what is a VM? What is a VM, virtual machine, and what is a container? And the main difference here is they're very close, is that this is essentially a replica of an operating system. And this is a subset of an operating system. And what that means is that it's more like a process than it is an operating system. And this is more like an operating system than it is a process. Right? So there's basically, that's probably the simplest possible way to explain, is like if I had a gradient here and I would say, process, and then we would say an operating system, right? Is that it's not perfect, but it's closer this direction to an operating system, and it's closer this direction to a process. And one thing is that the startup time is like, it can take like 2 to 4 minutes, so it's a little bit sluggish, but it has in theory more power. The startup time, we'll call this startup, for a container can be very fast. It can be like milliseconds to launch. This also, you could say, like complexity. The complexity might be a little bit higher than a virtual machine. You have to really understand what's happening, and this is more like a little easier to understand initially for people. But there's a lot of ways to talk about these. But what is a VM and what is a container? These are just a few ideas of how you could differentiate. So the build servers, one thing also, you'll see build servers are typically using containers. Virtual machines are more like kind of dev environments, right? And these are like Cloud9, for example, is a virtual machine. So let's get into launching a virtual machine. Let's say that you want to do this on any cloud platform, AWS, Azure, Google Cloud. One of the things to be aware of is like, what are you going to do with it? How are you going to use it? If it's fully managed, like in the case of Cloud9, that's awesome. We can just I'm just going to let that one go. That's an awesome way to do it. But a lot of times you'll have to kind of tweak it a little bit. And so what I'm going to do is I'm going to go back to the console here, log in again. I think it's going to ask me to log in, and I'm going to launch something called a spot instance. And why I like spot instances is that they are, it's like eBay, where I can bid on these servers and I can save a lot of money. So if you know what you're doing, kind of going back to the gym membership analogy, you can save a ton of money by using spot instances. So in this case, this was the Cloud9 environment. But what I'm going to do is I'm going to click on this button here called Spot Request. And what I like about Spot Requests is that I can actually kind of do bargain hunting, right? So I can go, okay, let's see, we got this. Well, how cheap can I get it? And Amazon only charges you by the second. It's the first minute they charge you the full first minute. Then after that, they only charge you by the second. So I can go here and, for example, just look at how much of a savings I get. It's normally 11 cents, but I can get it for 0.02 cents, right? So it's a huge saving, like 5 times savings here. So what's awesome about this is that I can just bid on it and try to get it. So I'm going to say request spot instance, and then it gives me some questions and, do I want to do load balancing, flexible, big data? Let's just pick this one. This is just kind of like a general purpose one. And then from here, I have these options of what are the kind of images I can apply to my spot environment. I think this is an interesting one, the deep learning, because if you are doing things with, cloud computing, this can be really, really handy. There also is, Red Hat Linux, SUSE Linux, all kinds of different machines here. I'm going to pick, though, a deep learning base AMI like this. And then from here, I can say as spec or as instance. And so this doesn't really matter. Again, it's kind of like bidding on like a hotel or something like that. The only other things I need to be aware of are that this is critical if you want to shell into it, is you have to create an SSH key pair. And so if you are creating a virtual machine, typically this is something to be really aware of. So I'm going to go through here and create a new key pair. And we'll just call this demo spot. And I'm going to use the PEM format, which is the kind of the standard for SSH here, because I don't use Windows. There we go. And it's going to just throw it on my desktop, I think. Yeah, there we go. Throws it on my desktop. Okay, great. If I go back here, I can refresh this, and I think it should be spot demo or something like that. Demo spot. Yeah, demo spot. There we go. Demo spot. And then for additional configuration, I could put additional storage. I could do all kinds of stuff. Now, the other thing to be aware of that's really tricky is that you also need to make sure that you allow yourself to connect to the machine. This is one of the easiest ways to make a mistake, is you don't open the firewall inside there. So what I typically do is I have some security groups here that I set up, like spot instance security group. And I think I also have one for mounting elastic file system. So I can mount spot instance elastic file system. And these are, I'll show you those security roles in a second. That's pretty much all you need to know about, other than if you wanted to make API calls, you would have to give it an IAM role, which is like a security role. And you also could put like boot commands in there, like install these packages, run some bootstrap script or whatever. So from here, the only other thing to be aware of is that I can tell it what kind of capacity. For in this particular scenario, I think just one is totally fine. And then I also can tell it to do a fleet request, which is recommended, and that it'll just optimize for cost and just find the cheapest one that's kind of close to what I need. It's like almost like a rental car where you go in, you say, I want a mid-sized car, and they just give you one, right? It's kind of a similar concept. So there we go. We got this going. And I think this is pretty much ready to go here. If I say launch, I can go ahead and do a launch. And once this request goes, it's going to pick any of these, C3 large, M3 large. And in fact, if I click on it, you can see that it's active, and then it says pending fulfillment. So I can look further at instances now. And what this will do is it'll tell you when it picks one. So it looks like it found one. And so there we go, pending here. And this machine, I like to label it when I create one of these things, and I'll just call this spot demo to delete, right? Just so I know that this is a machine I would later want to delete. And you can just kind of hang out here and just take a look at it. It takes maybe like a couple minutes to get this initialized. But one of the things I can show you is that it's got these security rules here. So if I click on it, this is what I meant is I let it, this machine can talk on port 80, port 8080. I can let anybody connect anywhere in the world as long as they have the SSH key, right? And so these are just some rules that I would configure. If I didn't do this, I wouldn't be able to SSH into it though. So now that I've got that going, in fact, what I'm going to do here is I'm going to go back to my Cloud9 environment because it's still running actually, and I'm going to use it to connect to the machine. That's a really clever way to use the spot instances, is actually piggyback from Cloud9 into your spot environment. So from here, what I will do is, I think it was Hugo demo. I'll just open this thing up. Is I'm going to upload this SSH key into this environment, and I'm going to use this to shell into it. So I will just close all this stuff because we're done with this. Close this, and then I will just cd. I don't want to check in an SSH key into here. I'll just put this at the root of my machine here, and I can go here and say File, Upload Local Files, and I can select from my desktop that SSH key. There we go. And now that I got that set up, I'm ready to go. I can piggyback from this machine to the other machine. And one way to tell the difference here would be like uptime. That's one good way. If you're ever confused about, hey, where am I? Look, you can see that this one is up 55 minutes, right? So I'm going to now go to the EC2 instance, and it should be ready to go. I think it's demo to delete. Let's click on that, and I'm going to click on connect. And what it will do is that it'll tell me all these different instructions. So it makes it easy to connect. So I can just copy this and go back to my Cloud9 environment and just run this. So basically put this SSH key to 400 permissions. And I can just say, did it really put that there? I don't want that there. I'm going to go into this, go to CD Hugo. I do not want to check in an SSH key into GitHub. That is very bad. I will, because you could get your account hacked if you did that. So we'll move this. Let's go back here. There we go. So we'll just run that command again. Perfect. And then I'll run the next command, which is this. Here we go. And there we go. And so this is going to SSH, and now I'm in. And what's awesome is, look, I can do the uptime. This is a great way to know where you're at, is like, I've been up for 3 minutes. So they're very different, right? That's the remote machine. And then if I do a new terminal, I do uptime here. This is my local machine. This is my Cloud9, right? 57 minutes versus 3 minutes. And what's cool about this is I now have a completely configured deep learning spot instance that I can do all kinds of stuff. I've got NVIDIA drivers. I can do CUDA operations, all kinds of like fancy stuff on here. And then I think it's even got IPython installed, right? So with IPython, I can start using like TensorFlow and all kinds of cool stuff. Now, I think it even tells you instructions for how to use it. When you start it up, I think it says something about it. It when you first spin these up, it does take a little bit of time. But let's try import TensorFlow as TF. Well, there must be some way to source this. Let's look here. I can look at the README, and it might tell me. Let's see, fully managed. Check out SageMaker. Tools. Well, I don't know exactly which Python. I can say Conda maybe. I don't know what's exactly installed on here, but in a nutshell, I could start installing stuff. I mean, the one I could do, which I had mentioned I was gonna explore, was I could install Jenkins real quick to play around with that. So how do you install Jenkins on my spot instance? Let's do it. Let's go to Jenkins war file. So I can go to Jenkins, which is a kind of do-it-yourself build server, and I can just say I want to installing Jenkins. We want to do a war file here. So let's go to download, and oh yeah, generic Docker package. That's, I think, what I want is this. If I just click on this, what happens? Yeah, I think that's all I need. So I'm going to click on that, copy, and then I can just double check the Java's on here, which I think it is. Looks like it's on there. And I can say wget this. That looks like it's a little bit more complicated. So we'll say Jenkins war download. Go here. Here we go. Jump to war file. Let's do this. So we'll say copy this link. I will say Control A, get rid of this. Wget this. There we go. This is a Jenkins server, and I can just copy. I'll just put this next here. I can copy exactly what it says. It says do this, Jenkins jar, and this should run it locally on this particular machine. And does this work? Awesome. It looks like it's running. And from here, it should give me like a password that I can use to set it up. What's cool about this is, like, if you wanted to set up a really sophisticated Jenkins system with with like all kinds of like advanced topology, you could do it. But from here, what I'm going to do is I'm going to go to the name of my instance, which is this, and I'm going to go to port 8080. So I'm going to go here, first copy this, go to here, and then go to port 8080, like that. And now I've got Jenkins set up. And I can go back to my file here, this little key password, toss that in there, and then this just kind of sets things up initially. Install the plugins, and it'll go through and set it up. So from here, it's actually pretty easy to do some similar things that I've showed before in the first lesson, which is set up a makefile, set up build servers, hook it up to GitHub. Much more complex than AWS Code Pipeline, or much more complex than GitHub Actions, but it is pretty powerful. But again, what I would say is that this is kind of a great way to demo this out. This is a great way to kind of demo this thing out and play around with like how you could set up Jenkins and what you could do. And the way I've typically done this is that I like to put Jenkins inside of NFS mount points, so that when Jenkins is triggered, it'll automatically deploy the code to NFS mount points. So I think that might be one of the best ways to use Jenkins. But let me just show you the hello world, how to test it out. Is we could go here and we could say, hello. Let's just make a quick hello world. Go OK. Set this thing up and just say test hello. And then you can just say run this as a build step and just say execute shell command. And I can literally echo hello, hello, and then say save. And if I click on build, it just executes a shell command. So it's a really simple thing, a build server. And if I look at the console output, you should say hello, right? Echo. Now, let me show you something a little bit tricky. This might be the last thing I'll show in this lesson, is that you can also create a virtual environment and launch it in there, which is pretty tricky. So I can say virtual environment, if it's installed. I might have to install one. Let's just see if this works though. does virtual environment already come here? Hopefully it does. If it does, then I can launch Jenkins in a virtual environment. And so I'll say here, then activate, run Jenkins again. And then from here, now that I've got this, I could actually install software and do all kinds of Python-based build operations. So if I go back here, I can create a new build process for Python, and we can test out some cool stuff there. So I don't know why Jenkins is getting angry here, but anyway, I don't know why Jenkins is, maybe because, I think because I need to give it the password again, or who knows. Anyway, long story short is that Jenkins, you can easily test out prototype Jenkins. It's like a throwaway environment by launching it inside of a shell in foreground mode inside of something like Cloud9. So that's how I typically would set it up. And then once you got it all configured, then you could configure a very sophisticated Jenkins. So I'm just going to kill all this stuff. I'm going to kill this Jenkins build server, exit this. I'm going to go back to my EC2 environment, and to kill the spot instance, what I will do is go to spot requests. You kind of kill it at the root. It's like killing a weed. Is you go through here and you say terminate spot instance. You say action. You say cancel request, and then also terminate instance. There we go. So that will definitely kill it. And then from here, this will make sure that your environment is not getting charged anymore. And I like to just double check, hey, is this thing really getting terminated? In fact, just to be extra sure, even though I told it to be terminated, maybe what I do is I also terminate it again so that I'm not messing up here. I can even terminate this environment if I wanted to as well. I could just say stop. Or even terminate. Let's try that. Instant state terminate. So you can terminate anything that you own automatically. So the last kind of wrap up thing that I'll say about the virtual machine and spot instance and everything is maybe just diagram that out, exactly what that is. So if you wanted to recreate this yourself, the key point of what this is and how it would solve problems is that inside of the AWS cloud, you again could use Cloud9, and we'll call this spot request and also prototyping, right? Because really we were prototyping out what Jenkins does, prototype. So Cloud9, we go through here, and then we also in EC2, we say, hey, I want a bargain deal. I want to get the cheapest car you got. We spin up a spot instance. We ask that to run. And then from there, if I want to do something really tricky, I could even mount the Elastic File System /NFS, which is pretty awesome. This thing, I could actually mount here like this, and I could kind of get this thing running. And then from here, all I did was I did an SSH, and I SSH into this environment, and then I could prototype stuff, right? In this case, I prototyped Jenkins, and maybe if I wanted to set up some sophisticated network file system based deployment, that's probably the way I would do it. And of course, you saw at the end, I just delete it all, right? So there's a lot of advantages to spinning up virtual machines, especially ones you can bid on, playing around with some stuff, then deleting it all. Especially for students and prototypers and researchers, you can spend pennies and you can get really incredible performance if you know the things that we just talked about. So it's probably a good stopping point right here.